Warning, CSE 2030 is not the same. Engineering in the next 5 years completely changes, and this is not just me saying it. Coding will be transforming. Right now, if you need 100 engineers to build a software, you would need 5 engineers. But those people will get jobs who are good at it, who know how to do engineering, who are the solution founders, who are the geniuses, and who have played with their minds in the next 4 years, who've already become the senior that they need to in the next 4 years of their life. So choose wisely. If you're going to a B.Tech degree right now, you have to be very wise in how you choose this. This is not a normal time for computer science or any engineering field. This is like the 1980s, where everything is changing every day. New types of computers and new types of things are coming. Just like that, the fields are completely changing now. And if you want to be hired in the next 5 years, you got to join a university, an institution like AESTR. And we've created this new course just for those who are ambitious, who want to be the leaders of engineering field in the next 5 years. And here's my take on why you should join AESTR for your B.Tech and my 7 points. Point number 1. CSE 2030, a curriculum for those who want to be hired in the next 5 years. We've created this course with the help of engineers like me and my colleagues who work in AI every day and who know how the field is changing and who will be the ones hiring you in the next 5 years. How we do this? We created 5 majors, 9 minors, 5 innovation labs, trainers from Apple, Google Cloud trainers from Google, master trainers who are my colleagues working in Silicon Valley, working all around the world, coming here to train the next prodigies of the talent that India needs, the talent that we need to hire in the next 4 years. Point number 2. This is a course founded, built and trained by real AI engineers. People like me, my colleagues, we have come together to train you guys on what we've been training in the last 5 to 10 years. We want to build the people who we'll work with the next 5 years. And that's why we see how the world is changing. AI engineering is a young person's game. Why do I say that? Because it evolves very fast. It's not a skill that you just learn and then just keep doing it. It's not copying a code and pasting that code. It is something that you create. You need to find that genius. You need to find that software. You need to find that architecture, that solution within that problem. So we've created this course with the help of AI engineers. They'll be involved in teaching this. Everyone who's part of this course, every faculty, every engineer is constantly working on building their own software product, is constantly working within our associated companies to build new softwares, to build new solutions, build new robots, build new embodied AI solutions, build new foundational models. And we teach what we learn as we train ourselves every day. I can 100% say this does not exist in any other institution in the world. This is basically like doing an internship for 4 years with your senior colleagues. You come here and you get trained by people who are learning that thing every day. Most of the engineers that would be your faculties or your teachers, your mentors, will be people who graduated, 4 years back, 5 years back. They've taken the experience and they're now working with us to build those softwares, and they're training you with what they've learned right then and now. Point number 3, in-demand AI careers of 2030. If you ask me honestly, jobs don't look like front-end engineer, back-end engineer, DevOps engineer, cloud engineer in the next 4 years or 5 years. You would not see anything like that. You would see people who are specialists in niche topics who are hired for their expertise in niche areas. So if I am a founder of an fintech AI company, a startup in fintech, I would hire an AI engineer who's worked on software plus finance in the last 3-4 years. If I start, say, a robotics company, I want someone who's worked at robotics and AI in the last 4 years. If I'm hiring someone, say, in bioinformatics, I again want someone who's worked in bioinformatics and AI in the last 4 years. So what do we have now? We need to train our students for those niche jobs. We picked up 20 most prospective careers of the next 5 years, according to us, and we made a list of it, and we created majors and minors according to it. We created our labs according to those prospects. So for example, we picked 5 majors to excel our students in specific fields, so they're experts of at least one type of AI field, one type of software field that they can account as their own. They can say that I'm a senior in that field. One is software engineering, one is cybersecurity, one is cloud engineering, and there's so many like that. So we've picked these 5 majors and minors based on the job profiles that we've accounted for in the next 5 years. And we've created 6 innovative labs that these students will go through to become the engineers of the next 5 years. Point number 4, boot camps, boot camps, boot camps. Our core philosophy is teaching by doing. There's a concept called cognitive apprenticeship, where a teacher does something and a student looks at it, then the student tries to copy that thing, and the teacher then tries to transfer that thinking model to the student, and then the student keeps practicing and keeps practicing and keeps practicing until the time they're better than the teacher. That's called cognitive apprenticeship, and all our courses have been designed around that philosophy. What my core belief is, if you want to be an engineer in the industry, you have to spend your time on the computer. You have to spend your time building things. An exam won't give you anything. A lot of theory will, yes, expand your knowledge, but won't make you a good engineer. A lot of reading books, a lot of reading papers, magazines, nothing will give you as much courage, as much needed, horsepower to build products as you would by actually doing those things. So as an institution, as any institution of engineering, we need to give our students that place within our institutions, within your college, within your degree. And a college, a university, an institution has to give you the space to build things. And that's what we're trying to create. A boot camp is a space where we tell our students to work from 9 to 5 for a month, just trying to build a software, and we grade them on that. We ask them to create their own degree. We ask them to create their own personalized Btech of how they want it to be created. If I want to become a fintech AI engineer, I want my student to make that fintech AI software when they're doing that degree. And if they can do that in a year, and while they're spending that time, I will give them that grade on that. Why would I give them a grade on physics? That doesn't really matter. So you create your own Btech degree, and that's what becomes the great Btech degree that you will come out of. You make your own degree, you spend time on it. We will grade you on what projects you do, what work you do, how much time you spend on it, how much you interact with us. This is a new way of how engineering should be taught. This is from all of us who went through this Btech process. We looked at how things were wrong, and we found that, okay, if I wanted to be an ideal world and create my own university and create my own institution, this is how I would do it. And that's what exactly we did. We created a course by engineers and for engineers. Point number 5, innovation labs of 2030. We've created labs that do not exist anywhere on this planet in an engineering undergraduate college. So we took the experiences of mine, my colleagues, of industrial people who work with us, engineers from Silicon Valley, engineers from New York, engineers from London, who've come together to create this course. And we thought, if what time we spent while doing our PhDs, the labs that we were in, if we could do that exact same time while we were doing our undergraduate itself, we would already be so much senior than before. We would already know so much more. So we created 5 extremely advanced engineering labs that do not exist anywhere else. Number 1, foundational model lab. So all the machine learning, all the engineering in computer science right now has to be based on foundational models. Our students have to know how to build foundational models. Our students have to know how to fine-tune LLM models, how to use them to your advantage, how to use transformer models and put your own data on top of it, how to refine it, how to do feedback, how to do RLHF. And when you know all of that, you will be able to be an engineer that will be hired by OpenAI, an engineer that's hired by Google, the next big AI companies. Second, embodied brain lab. Embodied AI is a concept surrounding engineering every day today. You build robots, you build self-driving cars, you build exoskeletons, you build your robot dogs. Everything is done in embodied brain lab, and we use our patented brain technology where we are combining multi-agentic systems. It's a very advanced technology. Very few people in the world and companies in the world know this. This is built in-house by our own engineers, and we're building softwares on top of it. We're building companies on top of this technology, and we'll be teaching our students this while they're here. So you're getting the top 1% knowledge right here within India, within AESTR by Gyanvihar, the knowledge that engineers in Silicon Valley are using today to build applications in Y Combinator. So embodied brain lab. Third, soft brain lab. The same type of technologies used to build the robots, will be used to build the futuristic software robot experiences. If you're building a hospital app, you'd create this ecosystem where I as a customer is attended by an AI robot on a screen, a reception that takes me through this process. Then I meet this doctor, they follow up, they ask me how I am, they follow me, and that's kind of service that only AI can provide. Those are the kind of apps of tomorrow, and that will be built by tomorrow. Tell me any IIT that knows how to build that. Tell me any institution in India that knows if that kind of future exists. We are creating that, that's why we know, and that's what we are teaching our students. Number 4, RISC-V chip design lab. Who will design the future semiconductor chips that the Indian government is pushing so much right now? The semiconductor industry in Delhi and Tamil Nadu, everything is being built around us right now. They need engineers who can build those chips, and they need AI engineers who can train AI to build those chips. And that's what we'll be building in this lab. Number 5, your augmented human lab. The future of how humans will interact with robots. The future of how humans will interact with technologies covering your vision probes, your holography, your lasers, your design, the UX experience, everything will be done in this lab. So these 5 labs, the innovation labs, are our core and the crux of this course. The students, we believe, if they even go through 2 or 3 of these labs during the next 5 years, 4 years, if they build seniority in these courses, they'll become these senior engineers that we are aiming to make them into. They'll become the engineers that would be the top of the game, the top of the chart, the geniuses that will be hired by the best companies in the world in the next 4 years. Point number 6, AESTR, quality assurance outcome. The pathways that we've created out of AESTR are quite straightforward. We're very stringent on what we want out of our students. We want to have that all our students have a positive outcome, because we need to maintain the quality of AESTR by Gyan Bihar. So we give our students 4 of these options. 10% of the top students that we have will be going for 35 LPA jobs. We'll make sure that happens. We'll select our students accordingly. Our students will have a competitive environment within the institution. They'll be working 9 to 9 to prepare for these jobs. They'll become the seniors in the next 4 years while they're with us. They'll be working with us. We'll make use of them. They'll work hard, do internship with us in bigger companies, and we will make it so that they get hired for the best jobs in the world. Second, 2+2 and 3+1 opportunities for our students. This is a great opportunity for a lot of our students, where you get collateral-free loans to study outside of India, in US and UK with our collaborative institutions. You go and build your career in US and UK as an AI engineer, and we've collaborated with around 20-25 universities in these countries by helping our students also with the visa processes and all the processes that are involved with your career choices, your aim to become an engineer across the globe. Number 3, outsourcing of industrial training within our program. So we're talking to our industrial partners, and we're asking them that if you want to hire this kind of a person, you're going to take 1 year to train them. Why not give us that training process, and we train our engineer to do that same thing in 1 year. So this guarantees a median of 10 LPA for all of our students, and we're growing the numbers of industrial partners that we have. And this is a great partnership because they trust us. They know that we'll be able to teach that type of expertise, that type of practical experience to our students, that they'll be useful for those industrial training programs. Number 4 is our highly sought after entrepreneurship program, because most of the faculties and engineers who are teaching you this course, our master teachers, our global teachers, are all entrepreneurs and engineers. So we've collected a bunch of great people who've come together to teach you this. So they want new ideas to be created. They want to support this. They want to grow you. They want to help you grow as they grow. So entrepreneurship is something that we highly encourage in our students. It is said by Y Combinator and a lot of people that in the next 5 years, there will be 5 people billion-dollar companies or 1 people billion-dollar companies. Because if you are a computer science engineer, you know how to build softwares, you don't need a lot of people. You can just build AI to make everything for you, and you will be that person who owns that company yourself. So there's a big career coming ahead of you in that path, and we are here to help you. Point number 7. You've been taught by world's first humanoid teachers. We are training humanoids ourselves to become the AI teachers of tomorrow. We are training them, we're putting brain in them, and they'll be taking some of the classes to encourage our students, to motivate our students to see how the future is. AI will be teaching you itself. Humanoids will be teaching you itself. So the first institution to do that, we're making these humanoids ourselves and with our partners, and this is one of the most creative things. This shows the crux of this program. This is a program by engineers, and when engineers come to it, and when they have their brain on something, when they have their genius on something, they create new things. They want to build things, and they want to build you. They want to help you become the next great engineer. These were 7 points of why you should join AESTR for your B.Tech Computer Science program. All we say is, when you choose your B.Tech Computer Science, choose wisely, know things wisely, know how the world is changing the next 5 years, know that the computer science will never be the same again, and you need to be with people who know how it's changing, who are taking you along with them, who know how AI is changing and who are building AI.